finish semicircles because we didn't get that part done. We got everything else done that we really needed to, though, I think. All right, consider the equation of this circle. Solve the equation for y in terms of x. Now the question is, do you understand what that means? Solve the equation for y in terms of x. Does that mean I want it to say y equals, or does that mean I want it to say x equals? Y equals. It says solve for y in terms of x. So that means I want it to say y equals, and all the crap I have over there is just x. I don't have any other variable except x. So let's make that thing say y equals. Go. What's the matter? Oh, heavens, I don't know. I asked you where we stopped, and I thought this was it. Yeah, so we're going right here. How do I get y by itself? Not square. Square root both sides, yeah. So I get y minus 2 equals, now we're going to have to be real careful here. I'm square rooting both sides. Now, this is y equals 2 plus or minus okay. The question is, we have several questions, but one of them is, and don't write this down, is this equal to this? It's probably not. Yeah. No, it isn't. Is this equal to this? No. That's what I'm asking you. Is this equal to this? No. So what I'm saying to you is you cannot take the square root of this and the square root of this and say done. That's what you're trying to do if you want to say that the answer to this is 3 minus x plus 3 squared. Well, I'm not going to. You could, but there's no point. What we're going to do, and what I want you to write here in the middle box, we're going to write two equations, and we're going to write y equals 2 plus that, and y equals 2 minus that. And then I want you to go to your calculator. I want you to put this one in y1 and put this one in y2 and do a zoom 4, I think. Now, did you graph it?
Yeah.
What in the world is that?
I don't know.
Well, we'll look at that in a second. When you graph both pieces of this, y1 and y2, what are you getting? Yeah, we got to talk about that. You should be getting a circle. I will come there and look in a second.
I too got an oval. You might want to double check that you typed everything correctly.
Okay, listen. If you're getting an oval, do this. Do a zoom square. Zoom square.
Oh, yeah.
Huh?
But it's not far.
The only reason that your circle is not complete, are you saying it looks something like this?
Yeah.
That's because of the size of pixels. And what the calculator is wanting to do to connect those pieces is draw a vertical line, which this function mode won't do. See, we're in function mode, and a vertical line is not a function. So the calculator will not draw anything that it thinks is a vertical line based on pixel size. Here's the last question I have for you about this particular problem. Did you notice that your graph, if you did the plus first, you got the top half? Huh?
Yes.
And if you did the minus first, you got the bottom half? Now, did you copy this onto your paper? Have you got it graphed on your paper? I want you to do that because I want you to do something with your highlighter. What's this thing got? A center -3, 2, and a radius of 3, like so. Here's what I want you to do with your highlighter. I want you to highlight the positive one and go over here and trace the top half. So that will remind you that the positive piece gives you the top half. The negative piece or minus piece gives you the bottom half. Good. And I hope that will just be a reminder for you. Are you okay? Now, if you'll notice, look right here. This one says here just to graph the equation, and then over here it says to graph the two equations you got using two different colors. So we just did the two different colors over there. So don't worry about it. Now, let's look at it a different way. Solve the equation for x in terms of y. What do I want to do? Do I want to make it say y equals? Do I want to make it say x equals? Yes, because this is solve for x. So I want to make that say x equals. Go. So you got two equations, yes?
Yep.
Okay, our two equations then. X equals -3 plus, oops, let's just do, dummy. Let's just do the plus, and then we'll do the minus. You cannot put that in your calculator. Now, you got it on Desmos, and Desmos will absolutely do it. Now, question: what's the center of this circle? -3, 2. Now, I want you to go here, put it -3, 2, radius of 3. Go ahead and draw it. Now we're going to get your highlighters back. Mhm. Since we can't put that on our calculator, what do you think the top equation gives you? It's going to give you the right half. Good. It's going to give you the right half. If we went and plotted some points, what we would find is we are going to end up with the right half. So I can't even see that. I think there's the origin. 2. Dang, I can't even see that. 1, 2, 3. Does it go there? 1, 2, 3. So that gives you that half. This equation then would give you the left half. Folks, can you look at these equations and find the center? Okay, say that again. Now, back from Algebra 2, I think we talked about horizontals and verticals lying or telling the truth. Is this the actual x value? That's the x value of the center, isn't it? What's the y value of the center? Positive 2, right. So it's whatever number makes that equal to 0. Go back to the previous one that we did. Could you look here and determine the center of the circle? X value would be -3, y value would be 2. Good. That's right. Could you tell from here what the radius is? What? That's right. It's the square root of that number right there. Yeah, that's it. And that, ladies and gentlemen, is pretty much everything you ever want to know about a circle. I'm going to, what? Just like to take the test now, we're done, right? Listen, I'm going to write down a problem here. And I want you to tell me what you can figure out about the equation. X equals 2 plus the square root of 16 minus y minus 1 quantity squared. What can you tell me about the graph? Center is what? Center is 2, 1. You buy that? And radius is 4. Good. That's the last question I was going to ask. Is it a top half, bottom half, left half, right half? Why is this right half? Because it's x equals and it's positive, so it's going to give you the right half of a circle. Those are kinds of questions that you may see on a quiz or test. Okay, I'm good. Okay. An ellipse. In front of the White House, there is a very large lawn. It's called the ellipse because that's the shape. Okay. Can you talk to people if you're in the right spot? I don't know. Since it's open air and you don't have anything to talk into, I doubt it. Picture to the right is the graph of an ellipse. Before we begin to study the relationship between the equation and the graph of an ellipse, we first need some vocabulary. You will never have a vocabulary quiz, don't worry about it. Below you will find statements with words underlined. Based on the graph, see if you can come up with a definition of each underlined term. Obviously, I hope it's obvious, the center is the point 1, -3. Now, the first thing I'm going to tell you is the magic spots in that whispering gallery were this spot right here and this spot right here. So we'll talk about those spots. I hope so. The points 1, 2, and 1, -8 are the vertices of the ellipse. So what are vertices of an ellipse? It could be, but it could be long this way. It could be long horizontally. The longest, the farthest. That's right. They're the farthest points from the center. Write that down. Vertices, the farthest points from the center. I'm sorry?
In 4 directions.
4 directions. No, no. We'll get to question 2 in a second. The co-vertices are -1, -3, and 3, -3. The closest points to the center. Right. I hope you know that the word vertices is plural. Do you know what the singular form is? Vertex. Vertex. Verti? Yeah. Vertex. Look at number 3. The length of the major axis is 10. So from the what to the what? The distance between the 2 vertices is the major axis. The distance between the 2 vertices. If you look at the notes that Sparks wrote, you will see some other handwriting, and the other handwriting is mine. There's a variable that we use for major axis, and I wrote that into the notes, but I want you to have them. A is the distance from the center to a vertex. Tough, huh? Okay, so you need to write A is the distance between the center and a vertex. So you tell me this, what's the length of the major axis? 2A. 2A. If the distance from the center to a vertex is A, from here to here, that's A. And what's the distance from here to here? 2A. So the length of the major vertex is going to be, the length of the major axis, the length is 2A. Now let's talk about the minor axis. The length of the minor axis is 4. What's the minor axis? Perfect. The distance between the co-vertices. The distance between the co-vertices. Now I'll add in my little stuff. B is the distance from the center to a co-vertex. Whoops. B is the distance from the center to a co-vertex. So, if this distance is B, what's the length of the minor axis? 2B. So you need to remember that. The length of the minor axis is 2B. There are two other points on that graph, and those are the two sweet spots. Would you give everybody a ruler for me? Those are the sweet spots. Now, these 2 points are called the foci of the ellipse. Singular is focus. From this information, it's a bit far-fetched to expect you to be able to define what those are. So we're going to investigate. Now, what you're going to get is a ruler. Now, these rulers are not gridded off real fine. We're just going to do the best we can. Okay, I want you to be right here. Measure the distance from the top focus to one of the co-vertices. So I want you to measure the distance, well, snap. The distance between here and here. Yeah, diagonal. I want you to measure that distance right there. If you need to make a little mark on your ruler, these are very, very expensive rulers, so I'm not going to complain. They're really not. They were free. No, they were free. Yeah, they were free. If you need to make a mark on the ruler, feel free to do so. Now, there is another length in that ellipse that has that same distance, that same length. Can you come up with, using your ruler, another distance between something and something that has the same distance as what you just measured? Well, yeah, the other foci, yeah, but I mean, if you look, all of those are going to be the same. Something different.
Center to one of the vertex.
Really? Is it? Andrew says the distance from here to here. Is it? Is it? It is. What? 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 This distance is A, right? Hmm? What's this distance? That's B, isn't it? That's B. Now, hang on a minute. Hang on a minute. Hang on a minute. Hang on a minute. Look, this itself is not a right triangle because notice that this vertical piece is too long. What is the length of that green piece? It's A, isn't it? Didn't you tell me that that green piece was the same as this vertical red piece? Didn't you tell me that? No, hang on. This picture itself here is not a triangle because this vertical red piece is too long. Well, just a minute. 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 All right. Now it says construct a right triangle so that one leg of the triangle is the distance from the center to a focus. So do that. Draw that leg right there from the center to the focus. Draw that one. Then it says, I'm right here, the other leg is the distance from the center to a co-vertex. That's this one. Center to a covertex. And then the last one, the hypotenuse is from the center to a vertex. The hypotenuse is the distance from the center to a vertex. Wait a minute, what? One leg is the distance from the center to a focus. The other leg is from the center to a covertex. And the hypotenuse is from the center to a vertex.
That's the distance of it. The real weird way of saying that. It's saying that the hypotenuse is the distance.
Okay. Okay. Now, we'll do it my way. We decided that that green distance was the distance from the center to a vertex, right? But the distance from the center to a vertex for us is called A. The distance from the center, what's the only distance we don't have labeled? From the center to a, I've got the distance from the center to a vertex is A. The center to the focus. I don't have that. That's what I'm going to call that. Now you be careful. There's a relationship among those three sides. What kind of triangle have we drawn? A right triangle. Therefore, what theorem applies? The Pythagorean theorem. But it's not a squared plus b squared equals c squared, is it? It's c squared plus b squared equals a squared, isn't it? That's going to screw you up. Just screws me up. I still have to be very careful.
Couldn't you just label the other ones? Yeah, you could.
No, because the distance between, let me trace. This distance right here is the same as the distance from the center to a vertex, which is A.
Why can't you label it C?
We can't because it's A.
Is that like a law or you
You say like, why is it A? Why is it that called
On an ellipse, the definition from the center to a vertex we call A.
like everyone does? Oh,
Yeah, all the textbooks will call it A. Yes, yes.
You did say your definition. Do I
So I do check. We're going to call it a standard definition. Is that better? In an ellipse, b squared plus c squared equals a squared. Now, listen. We're going to write that way down here, okay? Now I'm going to write some words. Distance, that's a D. Distance from the center to, what the devil is that? The distance from the center.
Teachers, please pardon the interruption. Just a quick announcement. The Powder Puff game for today has been canceled and rescheduled. It will be rescheduled for a later date. Thank you.
February.
It's always the 8th graders, dude.
yeah.
Okay. I want you to write, Powder Puff is just girls flag football.
Why don't they just say girls flag football?
Heck yeah. All right. Distance from a center to a covertex. Did you write that down? Distance from the center to a focus. Did you write that down? Distance from the center to a vertex. Now, let's look here. The distance from the center to a covertex is B. The distance from the center to a, hold it, the distance from the center to a vertex is A, but we also know that A is this yellow length right here. And then the distance from the center to a focus is C. So I want you to look at this, if I can get it down there. The distance from the center to a covertex, we call that what? B. From the center to a focus, we call C. And the distance from the center to a vertex, we call A. This squared plus this squared equals this squared. If you can remember that, you can do anything you want to do with an ellipse. Next page. The question here, study the equations and the graphs and see if you can determine any kind of connection. Now, do you notice the first one is long vertically and the other one is long horizontally? Can you look at those equations and figure out anything about that graph? The center? What's the center of this ellipse? The center is negative 2, 3. Could you have found that from looking at the equation?
Yes.
Yes. X plus 2 and y minus 3. So we got the center. What are other important things about the ellipse from the front page? What? Vertices and covertices. The square root of which denominator? Which is the what? No, 2 is not a covertex. 2 is the... We never use the word radius. It's the what? It's B. Do you notice that the square root of 4, which is 2, is your B? It's a distance right there.
Yep.
And the square root of 16 is A. So A is the distance from the center to a vertex. So we know that this is 2 and we know that this is 4. We'll get there in a minute. Question. How do I know that this ellipse is long vertically instead of long horizontally?
Because that just shows it.
Then your numbers you have to
What?
This fraction is greater than
Okay, because A is greater than B, but how do you know which one's A and which one's B?
your x. So
Yeah.
So why?
your
It'll
4
be
is with
the
your
x
x
squared
and
plus
your
y
16
squared.
is with your y.
Is that dotted?
No, you're getting it. I think I heard what you said. Look at the second one. What we'll get done today is trying to get through the comparisons between the graph and the equation. Okay. What do you notice about this equation that you noticed in circles?
What?
What? I got to divide by crap. Why do I have to divide by stuff?
Because you have to have a more stable coefficient.
Because I got to have coefficients that are 1, right? So what do I have to divide by? Don't tell me A, B. You don't know that yet. Why don't I just divide by 2? Good, because I'd still have a 2 in front of that middle term. So let's divide everything by 4. Now, hang on a minute. If we do that, we'll have x minus 3 quantity squared plus over 2 plus y plus 1 quantity squared. But what's that going to equal? 25. What is that? It is, but it doesn't mean anything. In a general form of an ellipse, look right here. How do we make this thing equal to 1? And please don't tell me subtract 99. We're going to divide by 100. That's what we're going to divide by is 100. So what have we got? Over 50 plus that's the equation I'm looking for right there. Do we see the center? What's the center? 3, negative 1. Now, how can I tell by looking at this equation that this ellipse is long horizontally and this equation, the ellipse is long vertically?
The x term is bigger than the y term, the denominator?
Yeah. Do you notice here, which denominator's bigger? Which denominator's bigger? The one under x. Here, which denominator's bigger? The one under y. That's how you're going to know which way this thing's long. So A is going to be what? In this case, what's A going to equal? Square root of 50. A is going to be the square root of 50. What's B going to equal? 5. There you go. So from your center, you said square root of 50 is going to be A over 5 root 2. Tell me what 2 integers square root of 50 is between. Real close to which one? Are you okay that the square root of 50 is real close to 7? So if we go from the center, count out 1, 2, 3, 4, 5, 6, 7, and you can't really tell, but it goes just a tad farther. Same way this way, 1, 2, 3, 4, 5, 6, 7, and change. So your A is 5 root 2. You said B was 5. So what is B? I know it's 5. What does it mean? From the center to a covertex, from the center to a covertex, 1, 2, 3, 4, 5. Bingo. 2, 3, 4, 5. You with me? Oh, this is still the same thing. Identify the characteristics of that graph. What was the, let me see here. What are the coordinates of the vertices? Is that the same? Wait, is that the same picture? Oh, this is the picture. Okay, sorry. I lied. I guess we'll get just a teensy bit farther. Can you look at this? What are the coordinates of the vertices? negative 2, negative 1, and write that down. Negative 2, negative 1, and negative 2, 7. What are the coordinates of the covertices? 0, 3, and negative 4, 3. What's the length of the minor axis? How do you find the length of the minor axis? If I do this distance from a center to a covertex, it's double that. Remember, it's the distance between the two covertices. So 4. What's the length of your major? Is it 8? 1, 2, 3, 4. Now the last thing I'm going to ask you, and I'm not giving you homework off this lesson because we're not far enough. You just will have whatever the last one was if you finished it, right? Is on the semicircles? I mean, on the circles. Okay, can we find the coordinates of the foci? So let's see if we can do that. The distance from the center to a focus is what? What letter? C. The distance from the center to a focus is C. I need to find C. Do I know what A is? What is it? Look at your notes. What's A? Because the length of the major is 2A. So A is 4. What's B? B is 2. What's the relationship between A, B, and C? Which is the longest? A is the longest. If you can remember A is the longest, then it's going to be B squared plus C squared equals A squared. Okay? So let's see if we can finish that before the bell rings. Square root of 12. Is it plus or minus? That's a great question. Why? It's plus. That's right. It's plus because it's distance. So 2 root 3. Now, what are the coordinates? I know what the distance is from the center to a focus. What are the coordinates of the The center was 2, negative 2, 3, right? What's the distance? That's 2 root 3, right?
So it's just 3 plus 12.
Yes. So this one is negative 2, 3 plus 2 root 3. It's that. Leave it. Leave it. And what's the other one? What's this point here?
3 minus negative 2 or 3.
Negative 2, 3 minus 2 root 3. And on that note, we will end.
Good morning.